Hello guys, welcome to the video on Router CrossTalk library by Router Protocol. I'm Shivam, a member of developer team at Router. Let me tell you what Router Protocol is before we start any further discussions. So Router Protocol is an extensible multi-directional bridging protocol that connects current and emerging layer 1 and layer 2 blockchains to allow contract level data flow across them. At Router, we have multiple product suite. The first one is the Pathfinder API, which you can use to swap your tokens directly on the router bridge. The second one is the router widget, where you can integrate the Voyager cross-chain swap UI into your own UI. The third one is the router crosstalk library, about which we'll be talking today. At Router, we have around 10 blockchains already implemented, and we are focusing on implementing other blockchains also in the future. So let's talk about the CrossTalk library. So CrossTalk library is a library that can create cross-chain contracts with the ability to sequence token transfers as well as arbitrary messaging. You can create a contract, you can integrate this CrossTalk library into your contract, and you can make it cross-chain. You can swap tokens through your contract itself. You can pass arbitrary messages to other chains with your contract itself, and you can do both in a sequence also through your contract itself if you integrate the crosstalk library. So if we talk about the requirements of cross-chain systems, you will find mainly there are three requirements. The first one is the cross-chain token transfers. If you want to transfer your USDC from Polygon to BSC. So this is one thing that cross-chain systems require. The second is cross-chain instructions. So if you want to instruct your contract on the other chain to do something, so that is one of the requirements also. And if you want to do both of these in a sequence, so if you want to swap your tokens and then do something, that is the third requirement we have discovered. So with the crosstalk library, we provide a robust solution for all of these. So you can transfer your tokens, you can transfer arbitrary messages, as well as do both of these in a sequence using the crosstalk library. Okay. So most of the cross-chain solutions available today provide either token transfers or generic messaging or both, but in silos. So while we were creating a staking dApp, a cross-chain staking dApp, where we wanted to swap our tokens cross-chain and then stake the tokens on the other chain. So we discovered a problem that we do not have a good solution for sequencing the transfers as well as the instructions, right? So we created the crosstalk library for this, where you can swap the tokens as well as pass some instructions with a sequence that it should happen first and this should happen second. So how does it work and how you can integrate it into your contracts? So there are very simple steps. First is you need to inherit the crosstalk library into your smart contract. Then the second is that you need to deploy these contracts on all the chains you want to have your contracts on. And you, while transacting, you need to provide the data for ERC20 transfers or generic messaging or both, whatever you want to do. Then you need to provide some free tokens to your contract so that it can pay a bridge for the cross-chain services. So you do not pay directly to the bridge, but your contract itself pays it. So you need to provide some free tokens to your contract to pay the bridge. Okay. So what use cases you can enable using crosstalk? So there are multiple use cases, but we have listed only 4 or 5 of those here. But you can have infinite number of cases. The first one is the DEXs that can allow cross-chain swaps and staking together in one transaction for users. So you can transact on a chain A that you want to swap these tokens to the other chain and then stake it. So you can do that. Then you can create cross-chain tokens where you can burn the tokens on the source chain and mint them on the destination chain. Then there are lending protocols that can allow for cross-chain payments and settlement of borrowed capitals. Then you can have cross-chain NFT minting, where the fee for minting can be taken on one chain and the NFT can actually be minted on the other chain. Then there are some other things like cross-chain prediction markets and so on. So let's now move on to the demo for the router crosstalk. So you just need to go to github.com and search for the router protocol. And you can find the router crosstalk sample library. Okay. Then you just need to go to this branch and you can check the code here, but we'll show you a demo. So we'll fork this branch. Not actually fork, we'll clone this branch. Okay, so I've actually cloned it already. So I'll move to my editor. You can see this is the sequencer staking branch and it has all the contracts and stuff here. So here what we are creating is we are creating a contract where we can swap the tokens from one chain to another and then stake it on the other chain. So here you can see we have two contracts, the vault contract and the stake contract. So what vault does is vault actually implements the router crosstalk contract. Okay, you can see here it integrates the router crosstalk contract. It inherits it here and we initialize it here also. And it is used to create a cross-chain request as well as handle cross-chain requests from another chain. What stake does is we can call the stake function here in this staking contract, and it will take the tokens from the vault contract and stake it for the user. So what if we want to swap a token and then stake it on the other chain? So we'll just uh, call this stake cross-chain function. We will be providing the chain ID, the gas limit and the gas price, the ERC20 data and the swap data that we want to pass. I'll walk you through what each of these things mean. So here we just pass the selector to the function and we just pass all the params and then it sends the tokens also and then stakes it also on the other chain. Okay, so let me walk you through the vault contract as well as the stake contract first. Okay, so to integrate the router crosstalk library, you just need to first inherit it and then you need to initialize it. So you need to initialize it with the sequencer handler, ERC20 handler, and the reserve handler contracts. All of these can be found at dev.routerprotocol.com. So these can be found at dev.routerprotocol.com, where you will find documentation to the sequence, this crosstalk also, as well as all the addresses that you need to pass here. Okay. And then what is this token? So this is the token for which we are providing staking. So maybe it's USDC, maybe it's Polygon Matic, anything, right? So now there are some functions that you need to have in your contract to integrate the crosstalk library. So you can see these are the three functions which needs to be integrated to have crossing capabilities. The first is the set linker function. Second is the set fees token function. Third is the approve fees. So what these things are? The set linker function. So linker is the address of the admin who can link the contracts on different chains. So you need to deploy this contract on multiple chains, and then you must have some way to know what is my counterpart on other chain, right? So we need to link these contracts on different chains. So linker is the address of that admin who has the capability to link these contracts on different chains. Then there is a set fee token. So as I told you, the contract pays the fees for the bridging services provided by router bridge. So there are multiple fee tokens that we accept, and the list of those can be found at the same website, the dev.routerprotocol.com, and you can pass any one of those fee tokens here as your desired fee token. Then third one is approve fees. What is this for? So since your contract pays the fees to the bridge, you need to approve the bridge from your contract that it can deduct the tokens on this contract, right? So this is what approve fees does. Okay. Then here we have the approve tokens function just because we want to approve the staking contract. Once the tokens have reached here, we want to approve the staking contract that it can cut the tokens from our wallet. From our wallet, not our wallet, but this vault contract. So once I call the stake cross chain, my tokens from my wallet will be sent to the vault contract on the other chain, right? And then if we have approved the staking contract, then the staking contract will be able to deduct those tokens from the vault contract. So that is why we have the approved tokens function. Then there is a set staking contract. This is a regular function. This has nothing to do with router crosstalk. Then there's a stake function which you can come to the contract and stake. Actually, this is not a cross-chain function. This is the same chain stake function actually. Then there is a same chain unstake also. Now we have a stake cross-chain. So what we pass here is the destination chain ID. And this is not the actual chain ID of that chain, but the router defined chain ID. Like for Polygon, we have the chain ID 1. For BSC, we have 2. For Avalanche, we have 3. So the list of these chain IDs also can be found at dev.routerprotocol.com. So yeah. Now, this is the chain ID of the destination chain. So if you are going from Polygon to BSC, and for BSC, we have the chain ID 2 at router protocol. So you will need to pass 2 here. Then there is a cross-chain gas limit. So what is cross-chain gas limit and what is cross-chain gas price? So you have to pass the gas limit as well as the gas price you are willing to pay for the execution of your function on the destination. So if you have created a contract and you think that, okay, this should take this much amount of gas limit and this much amount of gas price to execute on the destination, then you have to provide that amount of gas limit and gas price. And this is how we'll determine the fees that we need to take from you for the cross-chain swap. But mind here, if you pass a lower cross-chain gas limit or gas price than required on the destination chain, your transaction may get stuck on the bridge and you will need to replay it. We also have a replay mechanism, but I'll talk about it later. So yeah, you have to pass a good amount of gas limit and gas price so that you will be able to uh, seamlessly use the bridging services. Then there is an ERC data and there is a swap data. These two are these two are for the cross-chain ERC20 transfers, right? And these two you will be able to get through our API, which I'll be showing you later. Okay, so you just need to pass the token addresses of the token on chain A to the token on chain B. You need to pass the chain IDs that I want to swap these tokens from chain ID this to chain ID this, and you need to have some data, and then you'll be able to get this two things, the ERC data and swap data. Now, what we are doing here is we are just creating a selector to the function we want to call on the destination chain. So we will have this function on this contract itself on the destination chain, and this function will be called when the request is received on the destination chain. So we'll encode the data we want to provide. So not actually encode, we are decoding the swap data to get the amount we want to swap. Then we are passing this data into an AVI encode. So what we are doing is we require an address as well as a UINT here, and this address is the address of recipient. So staking will be done in the address of this message sender, right? And then this is the amount of tokens that needs to be staked, right? So we are encoding the data that needs to be passed to this function, receive cross-chain on the destination. Then we have a generic data. What is generic data? So we just encode this selector and this data that we have created to pass to the other chain, and this creates the generic data. Now we have a params struct where we accept the chain ID, ERC data, swap data, generic data, cross-chain gas limit, gas price, fee token address, and these two parameters. So first one is the sequencing function. So if this is true, this means that you want to swap ERC20 first, and then you will call the generic function. What is the generic function? This receive cross-chain function. The second is if you pass false, then this function will be called first and then ERC20 transfer will be executed. So you want to transfer your tokens first before you start staking. That is why we have it true. So that ERC20 transfer takes place first and then we will call this function on the other chain. Then this is okay. So this is only generic actually. So what this means is if this function you are calling does not have to transfer any ERC data, right? So if you want this function to just call some function on the other chain and do not transfer any data, any ERC20 tokens, right? So you'll use true for it. If you want to do only generic message passing, you will pass true. And for swap data and ERC data, you can pass any dummy data. So that will not affect. Okay, then you just call this router send function with this params and it's done. Right. So you have created a cross-chain request for staking that will transfer your tokens cross-chain first and then it will stake it for you. Now, as I told you, we have a receive stake cross-chain for which the selector we have here. So this is the function that will be called on the destination chain. And what it will do is it will just call the staking contract stake function with the user as well as the amount we passed here. The user is message sender and the amount is this. So this function is called on the source chain and this is called on the destination chain. And you can see it has a is self modifier. What is is self modifier? So for security purposes, we want that no address can call this function directly. Only a bridge can call this function, right? And not also our bridge, but this contract itself will be only able to call it. And how we will achieve that? How will this contract itself call it? So when a cross-chain request is received on the destination chain, this function is called, that is the router sync handler with the selector and the data you passed in the generic function. So here's the generic data, you pass some selector and you pass some data. What this data is, it has the user address as well as the amount of tokens need to be staked. So this selector and data is received on the destination chain into this router sync handler function. And what this does is it checks if this is the selector to this function and we decode the data accordingly. So we know if it is a stake cross-chain function, then we must be receiving a user and an amount. So we decode it accordingly and we just call that function from here. Right. So only this contract itself calls this function. No other address or any contract can call this function. So this is how a cross-chain request that is received is handled on the destination chain. Now we have a replay transaction function. So maybe if you pass, a lesser amount of gas limit or gas price than required on the destination chain for a transaction to be executed, then your transaction may get stuck on the bridge and you will need to replay your transaction. And for this, you have to call this replay transaction function. And what happens here is you pass the nonce for that transaction, you pass the cross-chain gas limit, you pass the cross-chain gas price. And this is the updated gas limit and gas price you are willing to pay for replaying your transaction. Then it will call the router replay function, which will replay your transaction on the bridge. Now we have a recover fee token function, but this has nothing to do with CrossTalk integration. This is just because this is a testing contract, and if I pass some fee tokens and something goes wrong, I want to recover my fee tokens so that I can use it with my updated contract. So that is why I have this function, but it has nothing to do with the cross-chain contract. Okay. Now, so we learn that we need to initialize the sequencer crosstalk with the address of sequencer, the ERC20 handler, and the reserve handler. We need to create these three functions that are necessary for cross-chain swaps and generic message passing, that are the linker address, set fee token, and approve fees. Then we need to have three main functions, which are a cross-chain sending function, which will use to create a cross-chain request. Then we'll have a router sync handler function, which will handle the cross-chain requests received. Then we'll have the replay transaction function, which will be used to replay the transaction. So only using these simple steps, you can integrate the router crosstalk into your contract. Now we have the staking contract, and actually this does not do anything. It just have the vault address and the token address that need to be staked. It just maintains a balance of the staked balances, uh, a mapping of the staked balances according to the address, and it just transfers the tokens to itself and updates the mapping. So that's the only thing it does. Okay, so let's now talk about the deployment and the config of these things, right? So we have created a very simple system of deployment. So we have a one-click deployment process here in this contract module. So we have a deployments folder where we have the sequencer deployments.json. What happens here is you just need to pass the things you want to provide to your contract. So we need to have the sequencer ERC20 and reserve handler addresses in the contract to initialize the vault. You can see here. We also need to have the token address, right? So we have the sequencer ERC20 and reserve handler as well as the token address here. So this token address is actually the USDC on Polygon. All right, this is the USDC on Polygon. And fee token is also USDC on Polygon, and the token we want to stake is also USDC on Polygon. Okay, now the linker is my address actually. So this is the address of admin that has the capability to map the contracts on different chains. Similarly, for AWAPs also we have the addresses, and these addresses, the sequencer, ERC20, and reserve handler addresses, you can find on the official documentation, the dev.routerprotocol.com. Okay. Then this is the USDC on Avalanche. So we are using the fee token as USDC and the token to be staked also as USDC on the other chain. Then we have the linker address. So this is the linker. This is the same address. You can see this is my address actually. Okay. So once you have done this, you'll just need to go to the tasks, and we have all the tasks here. So one is the deploy vault. What this does is it takes the data from your deployments file, the one we just created, and it just initializes the vault contract here, and it stores the address of the vault into that file directly. Then it sets the linker on this contract, it sets the fee token on this contract, and it approves the fee token on this contract. So these pretty much does all the config for us. Then we have a deploy stake function, which will just deploy the staking contract. Then we have set fee token, set linker. So all these are called inside some master task, like deploy vault calls this set linker, set fee token, and approve fees, and so on. Then we have a deploy all task, which will actually do all the things for us. It will deploy the vault, it will deploy the stake contract, it will set stake contract on the vault, and it will approve the tokens. So what is approving the tokens? So once we receive the tokens on the vault contract, we want the staking contract to be able to deduct those tokens from the vault contract. So this just approves the vault contract from the staking contract to deduct the tokens and stake it. Okay. So once all these things are done, these four things, we need to map those contracts, and for that we have a map contract task. Okay. So here is the map contracts task. What you need to pass here, we need to pass the chain ID and n chain ID. What is the chain ID? So chain ID is the destination chain ID defined by router. So example, you have deployed your contracts on Polygon, BSC, and Avalanche. So from Polygon, you need to map your contracts to BSC and Avalanche. So for BSC, we use the chain ID 2 for BSC, and we use the chain ID 3 for Avalanche at router protocol. And all these things, again, you can find on the official documentation. So chain ID 2 and chain ID 3. So for this chain ID is the destination chain ID defined by router. So when you are mapping from Polygon to BSC, then you will need to pass the chain ID as 2, And then the n chain ID is the actual chain ID of the destination chain. So for BSC, that will be n chain ID is equal to 56. For AVAX, n chain ID is 43114. Okay. So when you are mapping from polygon to BSC, you need to pass 2 for chain ID and 56 for n chain ID. And for polygon to AVAX, you need to pass 3 for chain ID and 43114 for n chain ID. Once you have done those things, then I think you are ready to go and test your contract on the Explorer or your UI. So let's deploy these contracts and test it out once. Okay. Now, so let's deploy these contracts on Polygon and Avalanche. So let's start with Polygon. First is Polygon. So we'll write the task npx hard deploy dash dash network Polygon. Right. We have a deploy task that will deploy the stake, that will deploy the vault contract, as well as set all the config on vault and stake, plus approve the stake contract to deduct tokens from the vault contract also. All the addresses it will take from the sequencer deployments .json in the deployments folder. So you can see it has already deployed the vault and set the linker address, the fee token address, as well as approved the fees. Right. Also, this address is stored in the sequencer deployments file that I'll show you later. Okay. So all the config and everything is done on Polygon side. Let's do it on Avalanche. Okay, so the deployment has started. So yeah, so all the deployments are complete here. Now we would also like to verify these contracts so that we can access them on the explorers. So you can see all the deployments have been completed and the addresses have been stored in the deployments file. Now for verifying it also, we have created some tasks. So if we call this verify all tasks, it will verify the vault as well as the stake. So let's do that. So we'll first verify on the Polygon network. So the verification has started on Polygon. Okay, so the Polygon verification is done. Let's do the same for Avalanche now. Okay, so the contracts are verified on both Avalanche and Polygon. Let's open it up. First, we'll open the contracts on Polygon. So we have opened the vault. Now we'll open the stake also. Similarly, we'll open the vault and stake on Avalanche also. Avalanche is no trace. This is the vault address. Okay. So we have the vault, we have the stake. Now we would like to transact from Avalanche to Polygon. So we'll send some fee tokens first to the Avalanche network so that it can pay our bridge. So we have kept Polygon as the fee token. Let me send some fee tokens to my contract, the wall contract. Let's say we'll send one USDC. Okay, so I've sent some fee tokens to my vault contract so that it can pay the bridge. Now we want to transfer some USDC from Avalanche chain to Polygon chain and then stake it on the Polygon side. Okay, so we also need to approve this vault contract from our main wallet so that it can deduct those USDC that we want to transfer to the other chain. So we'll open the USDC, we'll open up its contract and we'll approve our vault contract for it. So, okay, we'll copy the vault contract address and we'll approve it. This is the approve function. We'll have the spender address and we'll only give approval for some 0.1 USDC. For 0.1, we have to write 5 zeros because USDC is 6 zeros, 6 decimals actually. Okay, so now that we have given the approval also, we can go and try any cross-chain functions here. So you can see we have one USDC here in the contract itself to pay the fees. We have also approved it from here from our main wallet. So let's try to call stake cross-chain function here. We'll connect the wallet and we'll go to the stake cross-chain function. Okay. Now we need the chain ID. So for chain ID, for Polygon chain, the chain ID is one. Where you can find it, you can go to dev.routerprotocol.com. Here we have a list of chain IDs. So let me have a look. Okay, so supported chains. You can go here and check that Polygon is chain ID 1 for router. This is the internal chain ID. Polygon has one. We'll pass 1 as the chain ID here. Cross-chain gas limit and gas price. So I know that my function is not that big, so I'll pass a medium kind of gas limit. Maybe I'll pass, for the safer side, I'll pass 100,000. You can pass lower if you want. I think this is not a complex function, so it should work with lower amounts also. But I would just want to be on the safe side. For cross-chain gas price, we can go and check the Polygon gas price currently. It's 40 GUI. So we'll pass 50 GUI. 50 and 9 zeros. Okay. Now to get this ERC and swap data, that is for ERC20 transfers, we'll use an API and I have written a script to get this data. So you can go to the scripts folder and get sequencer data. So here you have this basic URL and then you need to pass some parameters. So in from token address, we are passing the USDC on Avalanche. The to token address, we are passing USDC on Polygon because we want to transfer USDC on our Avalanche chain to USDC on Polygon chain. And we want to transfer an amount of 0.01 USDC. 4 zeros means 0.01 with 6 decimals. Now, source chain ID is Avalanche, destination chain ID is Polygon 137. Fee token address is USDC on Avalanche, as we discussed earlier. Recipient address. So here, what recipient address should be? So we want to send our tokens from Polygon, from Avalanche to Polygon, but we want to send it to the vault contract on Polygon so that the stake contract can take it from the vault contract, right? So here we'll pass the stake vault contract's address on Polygon. So this is the vault contract address on Polygon. So we'll pass this address as the recipient address because the stake will deduct these tokens from the vault contract. So we need to specify vault as the recipient address. Now, is this the native? What is this? So if the destination token is a native token of destination chain, if we wanted to convert this USDC to Matic token on Polygon, then this should have been true. Otherwise, this should be false. Okay, now we construct the query URL here and we query it here using Axios. So let's run this script once. This is a sample script. You can use it in your project to do it dynamically. So it's in the scripts folder and name is get sequence. So when it runs, it will give me the ERC data and swap data. I just need to pass those parameters to the function and we can do the transaction then. So we have the ERC20 data here. So I will go and paste it on the vault contract. Okay, we have the swap data also. So this is the data that we pass to the bridge for ERC20 transfers. Okay, so we are getting some issues here. So let me check. So I figured out what the issue was. The issue was that, so do you remember earlier I told you about the linker address? That the linker address has the capability to map the contracts on different chains, right? But we did not map it. So let's go and map it. So from Polygon, we want to map our contracts to the Avalanche chain. And from Avalanche, we want to map our contracts on the Polygon chain. So let's run the task, map contracts. What we need to pass, one is the chain ID, which is for Avalanche to Polygon, we'll use the chain ID of Polygon. So router spec chain ID is 1 and the N chain ID is 137 for Polygon, and this is on the network Avalanche. So from Avalanche, we are mapping Polygon. Okay, mapping is done. Now from Polygon, we'll map Avalanche. So for Polygon, we'll have 43114 here and we'll have chain ID 3 because Avalanche has chain ID 3 here. You can see. So this is Avalanche has chain ID 3 and this ID is 43114. Okay. Now we'll do the cross-chain swap. And you can see it's okay. Now we have done our transaction here. It takes some time to go to the destination chain. But here we can check we do not have any staked balance right now. So we can go and check the staked balance in the contract and we can pass our address here. So you can see when we query it, we find it 0. Okay. Now let's wait for some time and we can check what happens. So it has not come yet, but let's wait. So now you can see here that the balance has been updated to 10,000. What this means is that the USDC you paid on the vault contract in AVAX has now reached the Polygon network and is staked here. So I think that completes our tutorial. Thank you guys for being with me and I wish you all the best. Thank you.